Hello future engineers, welcome to my YouTube channel. If you're new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends. That's one way you can keep me going, inspired and refreshed. Now if you find my videos interesting and important to your studies, also please don't forget to subscribe. Sorry, it's example 26 on finding the resultant of concurrent and coplanar forces. Two tensile forces, one of magnitude 60 kilonewtons and the other 90 kilonewtons, meet at the point 4, negative 3, 2 meters. The 60 kilonewton force also passes through the point 213 meter, that point, while the 90 kilonewton force passes through quantity negative 1, negative 1, 5 meters. Determine the resultant vector. So in this case, the force should be transformed into rectangular components in vector form according to the formula on force resolution. Magnitude of force divided by the distance where that force is directed to times the quantity x component of distance I, position vector rather, then y component of distance j plus z component of distance k. Those components are simply the terminal coordinates of the point minus the initial coordinates of the point. So the terminal would be the other point and the initial would be the point where the two tensile forces meet. So in this case, solution, this is the expression in vector form for any force magnitude over distance, quantity x terminal minus x initial I plus quantity y terminal minus y initial j, then plus quantity z terminal minus z initial k. So that's the way the force is being represented in rectangular vector form. So distance 1 is square root of, because the 60 kilonewton load begins at 4, negative 3, 2 and ends at 2, 1, 3. So it is 2 minus 4 quantity square plus square root plus quantity 1 minus negative 3. So 1 minus negative 3 is 1 plus 3 square. Then 3 minus 2 quantity square. So distance 1 is equal to square root of 21 meters. So therefore F1 is magnitude 60 over distance 1 quantity negative 2i, because this is negative 2, positive 4j, then 1k or simply k, kilonewtons. Distance 2, F1 therefore is quantity negative 26.19i plus 52.37j plus 13.09k kilonewtons. Now let's proceed to distance 2. Distance 2 is negative 1 minus 4 square root quantity negative 1 minus 4 square plus negative 1 minus negative 3. So negative 1 plus 3 quantity square plus 5 minus 2 quantity square. So distance 2 is equal to square root of 38 meters. So therefore, F2 in vector form is 90 over square root of 38 quantity negative 5i positive 2j then positive 3k kilonewtons. So simplifying, F2 is negative 73.00i plus 29.20j plus 43.8k kilonewtons. So therefore, the resultant is simply F1 plus F2, this one plus this. So R is F1 plus F2. So combining similar components, so negative 26.19 minus plus negative 73 would be negative 99.19i, then 52.37 plus 29.20 is 81.57j, then plus 13.09 plus 43.8 is 56.89k. So for my viewers and subscribers, please prepare. You should like this method in finding the resultant because that's the trend. Do not just use the scalar approach. It should be vector approach because the vector approach is general and the sense is the same, and the application is uh, very extensive compared to scalar approach where the application is limited. And remember, the the vector approach is more general and the same as partly as that of the scalar approach. This is general and the best way. So for your part, we have two tensile forces, one of magnitude 60 kilonewtons and the other 90 kilonewtons, meet at 4 negative 3 2 meters. The 60 kilonewton force also passes through this point, while the 90 kilonewton force has direction angles with respect to x, y, and z axis of 48 degrees, 125 degrees, and 67 degrees. So you experience already how to transform a force in vector form with angular components given the direction angles. So determine the resultant force vector and show that this would be the results. So that's for your part. Pause the video and answer this problem.